Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of using the Pythagorean Theorem. This is standard 8.7c in the great state of Texas, and we are using item number 33 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the dimensions of a rectangular piece of paper are 8.5 by 11. That's your standard piece of paper, like printer paper. So let me just go ahead and draw something for us to look at. I always want to be looking at something. So if they don't provide a visual, it's always good to draw one on your own. So we've got our 8.5 right here. 8.5 inches. And here's my 11 inches. So Veronica folded the piece of paper along its diagonal. All right, so the diagonal is going to be like here, I guess. There we go. Which measurement is closest to the length of the diagonal in inches? All right, so really what we should notice here is what we just made was a right triangle. So we're looking for the measurement of that diagonal right there. And what we do know are we have two sides that are connected to this right angle that is in that corner. So these two are actually called the legs. So each right triangle has three different sides, obviously, since it's a triangle. The two sides that are connected to the corner, that is the right angle, are both called the legs. And this long diagonal which we're looking for is actually called the hypotenuse. It's got a special name. And what we found a long time ago, or someone named Pythagoras, was able to figure out that if you take the two legs, so we're going to call this leg side A, and this leg side B, and if you imagine them to be the sides of squares. So obviously if it's the side of a square, then it's going to be four sides that are the same. So let's call this the area of a squared. Then if you take this shorter side right here, there's always going to be a longer side, a shorter side. That's side B. So let's take that area and say b squared. If you take the area of a squared and you take the area of b squared, let me see if I can draw. I have to kind of ignore this other half of the paper here. So that hypotenuse is always going to be a little bit diagonal there. So let's just pretend that's a square. So this is going to be side C. And the area of a squared plus the area of b squared always equals the area of c squared. It doesn't matter what size right triangle you use, which is pretty cool. So that's how we can find missing side lengths on right triangle, because a squared plus b squared equals c squared. So we're going to call 11 inches our A, so that's going to be 11 squared. 8.5 inches is going to be our B. And we don't know what side C is. That's what we're looking for. So 11 squared plus 8.5 squared equals C squared. All right, well, I know my 11s. That's 121. So that's 11 times 11, not 11 times 2. I don't know 8.5, so I'm going to have to use my calculator for that. So that's going to be 72.25, and that equals c squared. And so if I add the 72.25 and the 121, I get 193.25 equals c squared. Now 193.25 is not an answer. It's not close to an answer because I have not isolated the variable. I still have an exponent. And I don't want all of c squared right here. I just want c, which means I need to take the square root. That's the inverse operation of an exponent, is to take a root. So since I squared it, I'm going to take the square root of both sides. So let me see what happens when I plug that into my calculator. The square root of 193.25 is going to give me just the side length of c. That's going to be 13.90143877, and it goes on too long. But the closest one is the answer here of D.